Today we're going to be looking at Section 8.4, Interval Notation, Finding Domains and Ranges from Graphs, and Graphing Piecewise Functions. The first example, we will be graphing inequalities. We need to graph the first inequality, x is greater than or equal to 3. If it's greater than or equal to, we use a bracket and we put it at 3 and it goes to the right. You'll notice that the chomper over here, the greater than sign, is also pointing to the same way as the graph. That will always be the case. So then if we look at x is less than 2, we put a parentheses because it doesn't have an equal to, and it's less than, and we just said that we would color the same way as the chomper or the less than, so we are pointing that way, and we color over the line and we have a parentheses because we are not including the 2. This, x is less than or equal to 4, we are including the 4 and it's less than or equal to, so we're going to open it to the left. And we also have x is greater than 1. That's a parentheses because it's not equal to 1, but it simply goes all the way to 1. And the solution for that complex inequality is simply that. Finding domain and range off of a graph, we're looking at the x values. Well, the x values we can see are -3 to 5. So we put brackets around them because these are solid dots, which means we include those points. So we have bracket -3, 5 bracket for the domain. Looking at the y's, we see that the lowest value of y is at 2. So we do bracket 2, 4, because it goes all the way up to 4. Again, those dots are solid, so that's why we're using brackets, because we have to include those endpoints. Example 3, we're finding the domain and range again. The domain of the x values would be from -4 to 2. We're using brackets again because those dots are solid. So it is bracket -4, 2 bracket. And we're looking at the y values, bracket -3 to bracket 3. So we have bracket -3, 3 bracket for the y values or the range. Going on to example 4, they're wanting us to evaluate at different values, f at 2, f at -3, and f at 0. This function is a piecewise function, and we call it that because it's restricted by the x values. X is less than or equal to 0, we use this equation. If x is greater than 0, we use this equation. So evaluating f at 2, we have to think about 2 is greater than 0, so we're going to use this equation. Plugging it in, we get a -2 minus 2, and we find that y is a -4. We already knew that our x was 2, so the point is 2, -4. When we try to find f at -3, we have to look at the piecewise function again, and it falls in here. It's less than or equal to 0, so we use that equation, and plugging a -3 in, we find that y is a -7. So the point is -3, -7. When we're hunting for f at 0, we have to go up to where it would be 0, and it's this one, so we're using this equation. Plugging a 0 in for x, we find that y is 2. So again, we know another point, and the point is 0, 2. Now we want to graph that piecewise function. So we have some points. We have 2, -4, which is right about here. We have -3, -7. -3, -7 is slightly off the chart, but it would be about there. 0, 2 is right here. I'd also like for us to look at this equation, and we can see that that y-intercept is -2, and I'm going to put a dot there. Actually, That's a -2 if x is greater than 0, so we're not including that point. So I'm actually going to put an open circle because we do not want to include that point. So here we have the graph if it is x is greater than 0, and here is the graph if it is less than 0. So let's take a look and see if that makes sense. If x is less than or equal to 0, that's a positive slope, and a y-intercept of 2 sure is. There's my y-intercept, and it is a positive slope going uphill left to right. On the right side, where x is greater than 0, we didn't include -2 because its x is greater than 0. It does look like that slope is a -1, so I think we're good. That's our graph of our piecewise function.